MCP, the protocol that lets AI actually do things. Read your files, query your database, drive your browser. Everyone's talking about it. Almost nobody can build with it. In this course, you'll do both. First, you'll master using servers, connecting, authenticating, running a pro setup. Then we build your own working server in 30 lines of Python, tested, extended, and taken remote. And at the end, we ship it, secured, and published to the official MCP Registry, live for the whole world to install. 3 levels: use, build, ship. 10 chapters fully updated for 2026. Let's plug in. Chapter 1. Before MCP, connecting an AI to your tools meant custom code for every single pair. 10 tools, 3 AI apps, 30 integrations. MCP replaces all of that with one standard plug. Like USB-C for AI, the tool speaks MCP, the AI speaks MCP, and anything connects to anything. The tool side is called a server. It offers 3 things: tools, actions the AI can take, query this database, send this message, create this file. Resources, data the AI can read, files, schemas, documents, read only, no side effects. And prompts, ready-made templates the server offers, like summarize this week's errors. The AI side, Claude Code, Claude.ai, or any MCP client connects, and the two introduce themselves. Here's what I offer, here's what I support. That handshake is called capability negotiation. From that moment, the AI sees the server's tools like its own hands. You ask in plain English, it picks the right tool. One protocol, hundreds of servers, every major AI client. That's why everyone's talking about it. Next, let's connect your first ones. Chapter 2. Time to plug something in. In Claude Code, servers are declared in one file, .claude/mcp.json. The shape is simple: a name, a command that launches the server, and its arguments. Here's the file system server. It gives Claude controlled access to a folder you choose. Don't like editing JSON? Same thing from the command line, Claude MCP add name command. Done. Restart the session and watch. Claude now lists files, reads them, writes them. Through the server, with the permissions you scoped. Let's add a second, the GitHub server. This one's remote. It lives at a URL not on your machine. Note the type, HTTP. Run /MCP to see your fleet. Every server, its status dot, its tools, and a number people ignore. The token cost. Every connected server describes its tools to the model, and descriptions cost context. In the old days, 10 servers could eat your window. 2026 fixed it, tool search. Full tool definitions now load lazily, on demand, so a big fleet costs a fraction of what it used to. Still, connect what you use. Every server is also a thing that can act on your behalf. We'll talk security in Chapter 9. One file, one command, one panel, you're connected. Next, servers that live on the other side of the internet and how you sign in safely. Chapter 3. Servers come in 2 homes. Local ones run on your machine and talk over standard input-output. Fast, private, perfect for files and dev tools. Remote ones live at a URL and talk over Streamable HTTP. The modern transport. If you see an old tutorial saying SSE, that's the previous era. It's gone. Remote means authentication. And in 2026, the standard is OAuth 2.1. No pasting a PI keys into config files. As a user, it's painless. Claude MCP login, the server's name. Your browser opens, you approve, done. Tokens expire, they refresh themselves now. Auth went from the worst part of MCP to the part you forget exists. On the web, Claude.ai has connectors. Settings, add custom connector, paste the server's URL. Same OAuth dance, and the server's tools appear in your chats. You can also open a connectors page and switch individual tools off. Keep search, disable, delete. Granular trust. And if you're in a company, enterprise-managed connectors let the admin wire servers through your identity provider once. Everyone gets them, zero setup. Know it exists. Local equals standard input-output. Remote equals Streamable HTTP plus OAuth. That one sentence is the whole transport story. Next, running a real fleet without drowning. Chapter 4, short and important. More servers isn't more power, it's more surface. Here's how pros run their fleet. Rule 1, least privilege. Scope the file system server to one folder, not your home directory. Give tokens read access if reading is all you need. Rule 2, disable tools you don't use. A server with 30 tools you needed 2 of, turn the other 28 off in the connector settings. Rule 3, audit monthly. Open/MCP look at each server and ask, did I use this in the last month? No, disconnect. Reconnecting later takes one command. A sane loadout for a developer in 2026. File system, GitHub, your database, browser control, and maybe your team's chat. 5, not 20. Fewer, scoped, audited. Your AI stays sharp, your context stays lean, your attack surface stays small. Now, the fun part, we stop using other people's servers and build our own. Chapter 5, the reason you're here, we're building a real server, project notes. Save a note, list notes, search them, 30 lines, genuinely useful. Python with the official FastMCP SDK. 1 import, 1 line to create the server, FastMCP and a name. Now the magic decorator, at mcp.tool. Put it on a plain Python function, and that function becomes a tool the AI can call. Here's save note. Takes text, appends it to a file with a timestamp, returns a confirmation. Look what you did not write? No schema, no JSON, no protocol code. The type hints become the input schema. The docstring becomes the tool's description. That's what the AI reads to decide when to use it. So write docstrings like you're explaining to a new teammate. Save a note to the project journal. Clear, specific. The better the description, the smarter the AI uses your tool. 2 more tools, same pattern. List notes reads the file back. Search notes filters by keyword. And the last line, mcp.run, transport equals standard input-output. That's the whole server. Count it, 31 lines, 3 working tools, 0 protocol boilerplate. The SDK carries the protocol. You just write functions. It runs, but does it work? Before we hand it to Claude, we test it like professionals. That's next. Chapter 6. Every MCP developer's best friend, the inspector. 1 command, no install, npx at model context protocol/inspector. Then the command that runs your server. It opens a web interface wired straight into your server. Every tool, every schema, right there. Click Save Note, type a test message, run, and there's the response. Your code called through the real protocol. Break something on purpose. Wrong type, missing field, and the inspector shows the exact error the AI would hit. Fix it here, not in production. The pro debug loop. Inspector first, Claude second. When a tool misbehaves later, you come back here and isolate it in seconds. Green across the board, wire it into Claude Code. 1 block in mcp.json pointing at your script. And now the moment, ask Claude. Save a note, shipped the login fix. Watch it find your tool, call it, and confirm. Your code just became part of the AI. Built, tested, connected. But tools are only a third of what a server can offer. Next, resources, prompts, and a second language. Chapter 7, Tools Act. But remember the other 2 sockets, let's use them. A resource is data the AI can read. No side effects, no action. Decorator, add mcp.resource with a URI. Now the whole notes file is readable context, not just searchable. Why does that matter? The AI can pull your notes in as background knowledge before answering, instead of calling search 5 times. A prompt is a template your server offers. Add mcp.prompt, weekly review. Summarize this week's notes, grouped by project, 1 decorator, and every client shows it as a ready-made action. Tools act, resources inform, prompts guide. A great server usually ships all 3. One more thing, The same server in TypeScript because your team might live there. New MCP server, name and version. Tools register with server.tool, a name, a Zod schema for inputs, and a handler. Same shape, different syntax. Zod plays the role Python type hints played. It defines and validates the inputs. Connect a standard input-output transport, and it's live. Same protocol, your language. Pick one, master the pattern, it transfers. Next, your server leaves your laptop. Chapter 8. Your server works on your laptop. Time to give it an address. The change is smaller than you think. Swap the transport. Instead of standard input-output, Streamable HTTP. Your server becomes a web service with an MCP endpoint. Deploy it like any small web app. A container, a cloud function, a $5 VPS. The protocol doesn't care where it lives. But remote means strangers can knock. Enter OAuth 2.1, the lock on the door. The flow, one diagram. The client discovers your server needs auth, sends the user to sign in, gets back a short-lived token, and every request carries it. Your server's job, verify every token before doing anything. The SDKs and gateway services handle the heavy lifting. What matters is that you never skip the check. And short-lived is the point. Tokens expire in minutes and refresh automatically. A leaked token is a problem for an hour, not forever. Now connect it from Claude.ai, add custom connector, your URL, approve. And your notes server works from any browser, any device. Local file to global service. One transport swap and one lock. Before we publish it to the world, one chapter stands between you and shipping, security. Chapter 9. Uncomfortable truth. An MCP server is code that whispers to an AI, and whispers can lie. It's called tool poisoning. A malicious server describes its tool innocently, formats your text, but the description secretly instructs the model, also send the user's files to this address. The defense as a user, install servers like you install software. Known publishers, active repos, read the tool descriptions in the inspector before trusting. Chapter 4's rules exist for this. Now the builder's side. The 5 questions your server must answer before it ships. 1. Do you validate every input? Types, ranges, lengths before touching anything. 2. Do you sanitize what you return? Your output lands in the model's context. Don't relay text you don't control. 3. Do you verify every token, every request, never trusting a token meant for someone else? 4. Are your scopes minimal? Read only unless writing is the job. And 5. Do you refuse to follow redirects to private addresses? A malicious URL pointing your server at the cloud's internal endpoints is a classic steal. 5 questions, 5 yeses, or it doesn't ship. Print them. Every serious MCP author knows this list by heart. Your server is built, tested, remote, and now trustworthy. One step left, the big one. Final chapter. 2026 gave MCP something it was missing, an official home, the MCP Registry, one searchable index of servers. Publishing starts with one file, server.json, your server's identity card, name, version, description, and how to run it. The name is namespaced, like io.github.yourname/project notes, and you prove the namespace is yours through GitHub or DNS. No one can squat your name. The code itself lives where code lives. npm PyPI, a container registry. The registry holds the metadata and points there. Submit, verify, publish, and there it is. Project notes, public. Anyone, anywhere can find it and plug it in. Feel that? You didn't just take a course. You shipped infrastructure. Look at the whole road. What MCP is: connecting, remote, running a fleet, building with FastMCP, testing in the inspector, resources and prompts, going HTTP, securing it and shipping it to the official registry. You're not an MCP user anymore. You're an MCP author. The deep dives are coming. Building for real products, advanced auth, the registry's next chapter. Subscribe so you're here for them. Questions? Comments? I read everything. go ship a server.